Hey students, are you here for another lesson? Today you'll need a calculator, and after this, please do learning activities 7.12 and 7.3. I will do another video this week to explain what's going on in those learning activities. I know it's a little bit hard, but we can go through them. But let's get started. Say hi to Karen for us. Hi, Karen. So we're going to look at some people, so how some people look and use volume, okay? Should be able to calculate the volume of a prism with a complicated base. So let's talk about this first with a warm-up. I want you to see if these are prisms. Go ahead and look at A, B, C, D, and to F. Pause this video and answer these questions. So which of these solids are prisms? And for each of the prisms, what does each base look like? Okay, so basically, remember with a prism is when you have a base, which is the flat part in the bottom, where it goes up and up and up, and the top part is similar to that base, right? So if I was to look at each one of these, I could say, well, A clearly has a base right there, and it's a cube, right? We can see the top part is this part right there, right? It's the same. The bottom is the same as the top, so that is going to be a prism. But go ahead and look at B. If we're trying looking at B, the base is more like in this face value now, right? If we look at the bottom to the top, it's not the same. But if you look at the face, so this face right here, compared to the backside, right? This backside of the back, that is clearly going to be the same as the front side. So there you have a prism as well. Looking at C, this should be a little bit easier, where you have the base in the bottom, and then up here, you have the top side right there, similar to that base, right? So that's for sure. Let's look at D. Is D going to be a prism? If you look at it, it's not going to be a prism, right? I can't find a face here, maybe on this side, but that side does not work either. Clearly in the bottom part, that's not going to be similar to the top, right? So that's not a prism. But look at E. You have here this part right here, right? And that's the same thing as its top, so that for sure is a prism. Last but not least, F. F, it has this middle point like that, right? But other than that, no other sides are similar, right? That kind of go flat top to each other. So therefore, D and F are no, and A, B, C, and E are yes, right? And there's your answers again, with a bunch of random stuff on top. We're going to look at a box of chocolates. So remember, usually during Valentine's Day, maybe your parents, maybe your friends, maybe somebody gets a box of chocolates, right? We're going to look at the shape of it and try to find the volume. So remember, box of chocolates is three-dimensional, right? It has that little heart on the face, and it's a prism because you have this part and, whoops, you have this part and you have the back as the same, and therefore those are prisms, all right? We're going to be chopping this up and trying to find the volume of it. Again, if I was to take this face value of it and put that heart right there, I can see the dimensions here. You can see that, well, it looks like the top, you got 2, 4, 2, and we're going to use these vertices right here, these points right here as our markers for that one, looks like. And we have one right here for a marker, and it looks like we got another one right there, right? So we're using all those different parts as a marker. We also have the height is going to be 2 inches, okay? And we're going to use this later to find the volume of it. Before we find the volume, let's go ahead and figure out which one of these methods would be the best. All right, so if I was to look at each one of these methods, looking at Lynn's, Jada's, Diego's, go ahead and think about which one would be the best method. To explain it, it looks like Lynn is using 2 trapezoids right here and 2 triangles, right? That seems to be her shape with that. So the idea is if I find the area, so area of trapezoid plus area of triangles, you can find this figure, right? You can find the whole base area of that heart. Let's go to the next one. This is Jada. Well, she made 2 triangles on the top, 1 rectangle, and then one and those and that big 3 triangle right there, right? So Jada made 4 shapes She made 4 shapes, and then she added them together. Added all to get area. So looking at Diego's is a little bit different. It's a little bit reverse of what we think, right? Instead of filling inside the shape, we're going to look outside where we have this square or rectangle outside of it. And what Diego did was he found the area of these triangles, okay, area of those triangles, and then he subtracted it to the square. So he took the area of a square minus areas of triangles. Okay, so he took the square, so area of square minus the area of the triangles. To do that, you take the square minus those little pieces, you should get the heart shape, okay? But what we want to know is which one's going to be the best method. So I'm thinking about which method cannot be used. Well, I think that we can't use lens. We can't use lens, okay? Use lens. Because we don't know the area of a trapezoid. We don't know these areas, right? We don't know what those are. So therefore we can't use those. But we can use these, all right? Because we do know the area of a triangle. So the area of a triangle is equal to base 1/2 base times height. Base times height. And then the area of a rectangle, that's equal to base times height of that, right? So we're going to start using Jada's and Diego's plan, okay? So if we're trying to find the area of the base, let's start with Jada. Looking at Jada, I know that I have this rectangle right here. Whoops, that rectangle right here. Well, that rectangle is going to have a base of 8, right? Combining these two. And then the height of that small part is 2, laying right there. I need to know, again, for these triangles, right? These triangles right here, that's going to be 4 because that's 2 pieces of that whole 8. And then the height here, the height is going to be 1, right? Related to that right there. Cool. So I have the base, the heights and the heights of those 2 triangles. Okay. And then I also need this height of this triangle. So that base is 8. The height is going to look like it's going to be 5. All right. So doing all the math together, I have the area. Let's see, the area is equal to this triangle plus this triangle plus the rectangle plus the big triangle. All right. If I do that, that's going to give me, let's see, that's going to give me, this is going to be 1/2 times 4 times 1 plus 1/2 times 4 times 1, right? Plus the area of the rectangle, 8 times 2, plus the area of a triangle, which is 1/2 8 times 5. Okay, so put this all in your calculator. You should get 2 plus 2 plus 16 plus 8 times 5 is 40. Divide by 2, that's going to give you 20. Add that all up, that should give you a total of 40 inches squared. Okay, so that is going to be my area of Jada's plan. Okay, so if I was to use Diego's, let's go ahead and make a new one of this. I'm going to try to, let's see. Let's make a new screen. So if I was trying to do Diego's, so now I want to do Diego right here. Okay. So we found that the area was 40, but let's go ahead and try doing Diego's. So again, Diego's is he wants to find the area of these outside triangles and then subtract it to the overall rectangle or the square. So this overall square has a height of, looks like 8 by 8. Okay. So the area is going to equal the square, the area of the square, minus all these little triangles. Okay. All these other triangles in green. So it looks like minus all the triangles. Okay. So we say area of all the triangles. So if I was to do this, well, the area of the square is 8 times 8 minus, let's go ahead and find these pieces. Okay, let me just erase all this to get more clear. Well, this one is going to be 1. This is a 2. This also is 1. This is 2. This height of this middle one is 1. And then the base is 4. And then these are also identical, but looks like we got a 4 and a 5 for this triangle. Okay, let's put all of these pieces together. So we got 1/2 for the first one on top left, times 1 times 2, plus 1/2 times 4 times 1, plus 1/2 times 1 times 2, plus these other two triangles in the bottom, 1/2 times 5 times 4, plus 1/2 times 5 times 4. This is crazy, isn't it? But we do know the answer should be around 40, so I'm going to try to put that all together, right? So that should give you, let's see, it should give you the area is equal to, I'm running out of room, that's 64 minus, looks like we got 2, or no, we got 1 plus 2 plus 1. I'm just doing the math down there, okay? I'm just putting it on my calculator, doing it in my head, but I'm trying to get all those values together. But the next one's going to be 20 plus another 20. Okay? Or not 20, 10. I'm sorry, 10. So all of this equals is 64 minus 24. And that gives you 40 inches squared. So that is the same answer as Jada's plan, right? Except Diego tried to do this bigger square and then subtracted these little pieces to make the heart, right? So the question comes to is, what was the difference about the base of this figure in comparison to other bases we work with? So Jada, when we found Jada was all inside, right? Jada was inside. She did the inside. But Diego, he looked at the outside. Right? So those are the differences. When you're looking at the base of these figures, you can look at the inside or the outside of the base, okay? So the question is, now we gotta find the volume using these two, using the numbers that we found. Well, remember, this is fairly easy because we know that volume is equal to your base area times your height. The base area is 40, right? And the height is 2. So it's just 40 times 2. So the answer of this volume should be 80 inches cubed, right? And that's the picture of our heart, little heart Valentine's chocolate box, all right? That's what we're trying to find. We found that the area is going to, or the volume is going to be 80 inches cubed, okay? Man, this is a lot of work in your head, isn't it? There's a lot of math for me. Let's do one more problem and call it good for the day, and probably for the week, to be honest. and then we'll just do more practice problems in the future, okay? All right.